In this video, we will be reviewing the binomial probability formula, which I know is not everybody's favorite, but let's get to it. All right, so binomial probability is basically if you have the probability of success and failure, you can find the probability that you will get X number of successes in a certain number of trials, which would be N. That is our crazy formula, but we know how to break it down pretty consistently. We have our combination of N choose X, probability of success to the X power, and then probability of failure to the N minus X power, where N is the number of trials, X is the number of successes, P is the number, the probability of success, and Q is the probability of failure. All right, let's do some examples. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability of surgery being successful on exactly 2 patients. All right, so first we need to identify our different things. So we have 90% success rate. That is our probability of success. We are going to call our probability of success P. 3 patients is N, because that is our number of trials. And then being performed on exactly 2 patients, that's going to be our X. And Q, if it's 90% success, Q is 10% failure. All right, so let's break this down. So first we have combination of 3 choose 2. Our combination formula would be 3 factorial over 3 minus 2 factorial times 2 factorial. As we can see here, n minus x times x factorial times x factorial on the bottom, n factorial on the top. All right, 3 factorial, let me fix that, would be 3 times 2 times 1. 3 minus 2 factorial would just be 1 factorial. So that cancels out with the 1, and then we still have 2 factorial on the bottom, which is 2 times 1. 3 times 2 is 6, 2 times 1 is 2, 6 over 2 is 3. So I'm going to write that over here in my final product. Probability of success raised to the x power. Probability of success is 0.9. X is 2. So I'm going to come in my calculator and I'm just going to do 0.9 raised to the second power. And that is 0.81. Put that in our final product. And then last but not least, we have probability of failure, which is 10% or 0.1, raised to the n minus 1, which is 3 minus 2. 0.1 raised to the first power is just 0.1. Anything raised to the first power is itself. All right, and now, so those are our 3 different pieces, remember, from the formula. We have our combination is step 1. Probability raised to the x is step 2. Failure raised to the n minus x is step 3. Now we multiply those together. 3 times 0.81 times 0.1 is 0.243, which would be about 24.3%. All right, let's move on. All right, we have another surgical procedure that has 85% chance of success. A doctor has 8 surgeries scheduled and wants to know the probability that 3 of them will be successful. All right, so let's go through this. 85%, that is our probability of success, which is going to be P. 8 surgeries, that's going to be N, our number of trials. 3 is going to be X, that's the number of successes we're interested in. And then Q, if success is 85%, failure would be 15%. All right, so now that we have identified our pieces, let's go for it. All right, N choose X. So we have 8 choose 3. 8 factorial on the top. 8 minus 3 factorial on the bottom times another 3 factorial. 8 minus 3 factorial would be 5 factorial. We're going to cancel that out. And then we're going to not go past 5. So we're just going to have 8 times 7 times 6. Sorry, I wrote that in the wrong order, but that's okay. And then on the bottom, 3 times 2 times 1, because we still have that 3 factorial. That is 6. On the top, 8 times 7 times 6 is 336. 336 divided by 6 is 56. So that is step 1. Let's write that. That's our first part of our final product. All right, probability of success, 0.85 raised to x the third. I'm going to plug that in my calculator, 0.85 raised to the third. And that is 0.614125. We're just going to round that off to 0.614. Probability of failure, 0.15 raised to the n. Oh, that's just say n minus x, not n minus 1. All right, so n is 8. X is 3, so it's 0.15 raised to the fifth. Plug that in my calculator. Oh boy, I get 0.000, 4 zeros, and then a 7. So we're just going to round that off to 0.00008 because it's 0.00075. So that 7, the 5 would bump the 7 up to an 8. All right. So now we have 56 times 0.614 times 0.00008. Remember, there were 4 zeros there. 8 times 0.614 times 56. That gives us 0.00275, which would be about 275 or 0.28%. So a very, very, very slim chance that 3 will be successful. All right, let's keep going. You are taking a 10-question multiple choice test. Each question has 4 answers. You want to find the probability of getting 6 correct answers if you randomly guess. Okay, let's identify our things here. So 10 multiple choice questions, so that's going to be our N. We want to know getting 6 correct answers, so that's going to be X. Now we need to identify P and Q, our success and failure rate. Probability of success in this case would be 25% because it's 1 out of 4. There are 4 choices. That means probability of failure, 75%. All right. Let's do our combination. We have combination of 10, choose 6. Oh, wait, that should be a 6. Sorry, not a 4. And this should be a 6, not a 4. Okay, sorry for the messy handwriting. All right, 10 minus 6 would be 4 factorial. We're going to cancel that out. And we're not going to do anything past 4. And then we still have, though, another 6 factorial. All right, so let's do this out. 10 times 9 times 8 times 7 times 6 times 5. 151, 200. On the bottom, 720. So 151, 200 divided by 720 gives us 210. So that's my first step. All right, probability of success raised to the x power, 0.25 raised to the 6 power. Plugging that in. 00244. Sorry, 3 zeros, not just 2. And we'll just round it off there. All right, and now Q, 0.75 raised to, again, that should say n minus x, to the 10 minus 6, which is 4. 0.75 raised to the 4th is, oh, I put to the 5th, not to the 4th, 0.316. There's decimals after that, but we're just going to round it off. 0.00244 times 0.316. Multiply the two together. 0.01619. And that would be about 1.62% if I round it off, because the 9 would bump the 1 up to a 2. All right, let's keep going. All right, we'll do 2 more. Probability of someone being left-handed is 15%. So that is our X. No, sorry, not X, P. That's our probability of success. You randomly select 15 people, so that would be our N. What is the probability? 4 of them, X, would be left-handed. And then Q would be 85% because if success is 15%, failure is 85%. All right, so let's do 15, choose 4. All right, 15 minus 4 is 11, so we're not going to go past 11 on the top. And then on the bottom, 4 times 3 times 2 times 1. So on the bottom, we would have 24. On the top, 15 times 14 times 13 times 12. 32,760 divided by 24. 1,365. All right. All right, probability of success raised to the x, 0.15% raised to the 4th. That is 0.000506. So we're going to do 0.00051 because it would be 506, but the 6 would bump the 0 up to a 1. All right, and now, hold on, okay. All right, and now let's do our Q, 0.85 raised to 15 minus 4 is 11. This is going to be a very small number. All right, 0.16734. Well, it's going to keep that at 0.167. All right, multiply the 3. 0.167 times 0.00051 times 1365 is 0.1163 if I round it. So that would be about 11.63%. All right. Last one. Probability of a basketball player makes a 3 show is 0.6. That is our X. Actually, you know what? I'm going to have you guys solve this last one. So identify the N, X, Q, and figure out the final product. All right, bye guys. And then after that, you will do your link it, continue your week 30 homework, and then any missing assignments for quarter three. At the end, sorry, quarter four. We're in quarter four. At the end of the class, please return any pencils and headphones borrow neatly. Leave any, clean out any trash out of your desk and push in all the chairs. Please do not leave a mess. That would not be good for the next class. And I will see you guys tomorrow. All right, bye.